Okay, guys, so this is page 22, lesson E7, tangent line approximations revisited. So we've done this before where we have used the tangent line to approximate a y value on the original graph. But now we're going to have to use concavity to decide if this is giving us an over approximation or an under approximation. Okay, so I wrote here, if a graph has any type of concavity, here's 4 like situations that would be involved. So here we have an increasing and concave up graph, decreasing concave up, increasing concave down, decreasing concave down. And I drew the tangent lines at a point, like on the graph. And in these 2 situations, the tangent line is underneath the graph. That means that if you're going to use the tangent line to estimate the graph's y values, you're always going to be getting estimates that are below the actual y value. So in the case of concave up, no matter whether the graph is increasing or decreasing, concave up alone will let you conclude that you have an under approximation. And then, so you really want to be thinking about this, guys. I know I'm just like talking at you, but this should make perfect sense. Down here, where the similarity is that we have over approximations for the tangent line, using the tangent line, but also the graph is concave down. That's why. It's the concavity that is making it so the tangent line will be above the graph, and therefore the y values on the tangent line will be higher, slightly higher than the y values on the graph, yielding an over approximation. Okay, so in short, guys, if f is concave up, then the tangent line will give an under approximation for y values close to the point of tangency. And if f is concave down, then the tangent line gives an over approximation. Guys, you don't have to just memorize that. Oh, actually, concave up, u, under, that's nice, okay? But it's even better, notice, use any patterns that you notice, but you really want to be able to visualize. Okay, so guys, in this, we're just going to do example 1. Potentially, we could do the examples on page 24, but I'm going to do number 2 in another video. Okay, so given that y of 1 is 7, y prime of 1 is -2, and y double prime of 1 is 9, use linear approximation to estimate the value of y of 1.3. Is this value an overestimate or underestimate? Explain. Okay, so guys, linear approximation, you need to find, it's really the same moves as if you were finding the equation of the tangent line. But then whatever value that they're asking you to estimate, you take that x value and you plug it in to there, and it will give you an approximation for the value on the actual graph. Okay, so I know that I need that. And by the way, guys, this y, when we find the equation of the tangent line, the y in this will not be the same as this y that they're giving us. Okay, so, alrighty. So x1, y1, tan. Okay, so x1 would be 1, because they're giving us the point of tangency is 1, 7. So 1, 7, and then m tan, this is y prime of 1, which is -2. Okay. So I am getting y. You know what, guys? No, never mind. Okay, so I was going to use a different variable than y in here, but I don't think it's necessary as long as you keep them straight. So this is y of, yeah, never mind. Okay, so -2 x minus 1. So y is equal to -2 x minus 1. plus 7. And guys, notice I'm not going to distribute the negative 2 because if I leave it like this, when I plug 1.3 in here, it's just the math is going to be super easy because it'll be super close. You know, I'll be getting a small number. Alrighty, so now, okay, I'm going to take, all right, so now y of 1.3 is approximately negative 2, and then I'm plugging it in here, so I get 0.3 plus 7. Okay, so let me do some math here. This is negative 2 over 1, some arithmetic, plus 7 over 1. So this is negative 6/10. And guys, I know that negative 6/10 reduces, but tenths is really nice because you just move the decimal place over 1. So I'm going to leave it like that. Oh, that's 7 over 1. This is 70/10. So this ends up being 64/10, which is 6.4. And you don't have to do it like this. You know, you could leave your answer as a decimal or a fraction, but this sort of math we might be rusty on. Okay, now, so this is an approximation for y of 1.3. Now, the question of this being an overestimate or an underestimate, and we maybe as we read the problem should have done this. Okay, so this here, this fact that y prime of 1 is a negative number tells us that the y graph is, or I'll say y of x. So y of x, the original function, is decreasing. All right, this is Susan's table. Now this here, this is the concavity. That's what's going to tell us the over or underestimate. So here we have y double prime of 1 is 9. That's a positive number. So y of x is concave up. Okay, so if you want, you could just draw a little picture here. It's really concave up is all we care about, but since we know it's decreasing, okay, the graph looks something like this, all right? And then let's say that this here, and there's no need to draw this picture, guys, if you could visualize it. But so this is the graph of y of x. And then this is, the tangent line that I just drew. So this is y equals negative 2 x minus 1 plus 7, or the tangent line that I just found. Okay, and just as a nice visual, so let's say that this point here, this point is 1.3, y of 1.3, okay? What we found is this point right here. So that is 1.3 comma 6.4, okay? And because we are so super close, guys, this is like a microscopic. You can't even really see this difference here. So 6.4 is approximately that value right there. And as you can see, the concavity is giving us an underestimate. Okay, so underestimate. Now, it's important, guys, that you don't mention the decreasing in your explanation because the decreasing has nothing to do with it. It's the concavity that is making the tangent line go under. Okay, so underestimate. Okay, now let me underestimate, and then I'll say since y double prime of 1 is greater than 0, the graph of y is concave up at x equals 1, which makes this an underestimate. Yeah, I probably was a little bit wordy there. You could have stopped here, guys. Concave up at x equals 1. That's enough. Okay, so that would be good. Underestimate. Okay. All right, guys, it's kind of long. So I'm going to split this up into 3 different videos.